Today we are going to do arithmetic series. Okay, so we just finished the arithmetic sequences. Now we're going to do series. A series is a sum of an indicated number of terms in a sequence. So basically we're just going to, sum meaning add up all of the numbers in the sequence. Okay, so if we have a sequence list, the series is the sum of all of those numbers. Okay, so S sub n represents the sum of the first number of terms of any arithmetic sequence. So if I say S sub 5, we're going to find the sum of the first 5 terms in the sequence. Okay, so there's a little vocab lesson. So arithmetic series, recall that a series is the sum of a sequence, and when finding the sum of an arithmetic series, we're going to use the formula S sub n equals n divided by 2 times a sub 1 plus a sub n. So the first term plus the last term of that sum that you want. N is the number of terms. A sub n is the first term. And a sub n is the last term, as I just said above. Okay? All right, so let's find the sum of the first 100 positive integers. Okay, integers meaning like your whole numbers, and we want the positive ones. So we have like 1, 2, 3, 4, blah, 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 all the way to 100, because we want the first 100 positive integers. That's a lot, okay? It would take a while to write those all out and then add them all up in your calculator. So that's why we're going to use the formula S sub 100, because I want the first 100 terms of this sequence, arithmetic sequence. N was 100 divided by 2 times a sub 1, which was the first term, so 1, plus the last term, 100. You are just going to go ahead and type that into your calculator. So 100 divided by 2 is 50. And we're going to do 50 times 1 plus 100, which gives us 5,050. Okay, you guys can type this all into your calculator at once if you have the fancy button of the alpha y equals, whoops, I don't know why I did that there. 1 plus 100. It gives you the same answer. Okay, so just a couple different ways to type that in. All right, let's see here. Now we are going to find S sub n for each arithmetic series described below. So, let me move this down just a little bit. There we go. All right, so let's see here. We have a sub 1, a sub n, and n equals 25. So I'm going to say the sum of the first 25 terms is equal to n was 25, so I plug that in, divided by 2, times a sub 1, which was 4, plus a sub n, which is 100. And I'm just going to go ahead and type that in my calculator. 25 divided by 2, so 12.5 times 4 plus 100. 1,300 is equal to S sub 25. Okay. Number 3. You have a sub 1, n, and d is -3. So that means that d, remember, is the common difference. Okay, so what we're missing here, we have a sub 1, n, we're missing a sub n. So we need to go find that first. So we need to find out the a sub 20th term because n is 20, so that's the last term. So find a sub 20 using the formula from yesterday, which was a sub 1, we know is 40, plus the common difference of d, so -3, times n minus 1. And that again, that formula was in your notes from yesterday. This is the arithmetic sequence formula, okay? All right, so let's type that into our calculator. Negative 17. That is a sub 20, which will go in the a sub n spot, okay? Oh, I should probably move that over. Sorry, I didn't realize it got cut off. Okay, so a sub 20 equals 20, that's n, divided by 2, times a sub 1, which was 40, plus a sub n, or the last term here, which was negative 17. So 20 divided by 2 is 10. We're going to do 10 times 40 plus negative 17, which gives us 230. Okay? All right, number 4. Find the first 3 terms in an arithmetic series in which a sub 1 equals 9, a sub n equals 105, and a sub n equals 741. So we actually want to find the arithmetic series, or I'm sorry, arithmetic sequence. So we're kind of working a little backwards here. We know that a sub n is 741. So here, this was the equation that we were dealing with. I'm going to use this little sticky note to refer us back here. Okay, so we have 741 equals n divided by 2, because we need to find out what number, what term number that, what the last term number is here, like where, like how far in the sequence we go. So we have 9, because that's a sub 1, plus the last term of the arithmetic sequence was 105. So let's go solve for n. So we have 741 equals n divided by 2. 9 plus 105 is 114. Okay. You really are, another way to write that is 114 n divided by 2. So you're really doing 114 divided by 2. So we get 741 equals 114. We're going to divide that by 2. 57 n. And then to get n by itself, I'm going to divide both sides by 57. So 741 divided by 57, 13 equals n. All right, so now that we know which term number that is in the sequence, we now need to find the common difference, because we know the first term is going to be 9, but we need to find the common difference in order to find the other 2 terms after that. So, all right, using the formula for the arithmetic sequence, which was this, okay? So a sub n is 105 equals the first term, so 9, plus d, we don't know what the common difference is yet. And then we know that n was 13. We found that using the arithmetic series formula, minus 1. All right, let's go solve for d. So we get 105 equals 9 plus 12d. 13 minus 1 is 12. All right, I'm going to subtract both sides by 9. So 105 minus 9 is 96. Equals 12d. Divide both sides by 12. And you can just do these calculations on your calculator. 8 equals d. So our common difference is 8. So from there, our first term was 9. We know that from the list. And then if I add 8, 9 plus 8 is 17. 17 plus 8 is 25. So these would be the first 3 terms of that arithmetic series. Whew, that was a lot of work. On to the back. We've got a couple more problems here. Okay? All right. Jamila is making a triangular block wall with building blocks. The top row has 1 block, and the second row has 3 blocks. The third row has 5, and so on. How many rows can she make with 100 blocks? So, first top row has 1 block, second row has 3 blocks, third row has 5 blocks, and so on is the key words there. Okay? So, we want to find how many rows can she make with a total of 100 blocks. So that's your sum, okay? So our a sub 1 is 1. That was the first term. Notice our common difference is 2. We're adding 2 each time. We have a total sum of 100 blocks. We don't know how many rows. So the how many rows is the n value that we're trying to find, okay? So we kind of have to use both of these formulas and kind of work backwards here, okay? So we know that the sum, the total sum is 100 equals, we don't know what n is. We need to divide that by 2. The first term was 1. The last term, we actually don't know what that is. So we have 2 missing variables here. Okay, so that is why we also need to use this formula. A sub n is equal to a sub 1, which is 1, plus our common difference of 2, times n minus 1. Let's simplify this off to the side here. So we get 1 plus, let's see, 2n when we distribute the 2, minus 2. So a sub n equals 2n minus 1. 1 minus 2 is negative 1. So what we're going to do here is substitute this in for a sub n right here, because that is what a sub n equals. So we get 100 equals n divided by 2 times 1 plus 2n minus 1. And then we can solve this. 1 minus 1 is 0. So we get 100 equals n over 2 times 2n. Notice that this 2n is over 1, so these 2's will cancel out. So we're left with 100 equals n squared. To get n by itself, we're going to take the square root of both sides. The square root of 100 is 10. So you get how many rows? You have 10 rows that Jamila can make with 100 blocks. Might need to watch that part over again through because there was a lot of math going on there. But some of these problems, especially these application problems, are going to require you to use both formulas, okay? All right, number 6 says find the indicated sum for each arithmetic series. So now we're just using good old arithmetic series formula. So looks like we want to find s sub 10. So n is 10. A sub 1 is 2 plus, we need the last term, so we need to figure out what the 10th term is in that sequence. So we have to use this formula here, okay? So the 10th term is going to be a sub 1, which is 2, plus, let's see, our common difference to get from 2 to 4, 4 to 6, 6 to 8, it looks like D is going to equal 2, like we're adding 2 each time. So I'm going to plug in a 2 right there. N is 10, and then minus 1. So a sub 10 equals, let's see, type that in your, type that into your calculator, 2 plus 2 times 10 minus 1. I got 20. So that 20 is going to get plugged in there because that's the last term of the sequence for 10. So then now I'm just going to type that into my calculator. So 10 divided by 2 is 5. And 5 times 2 plus 20 is 110. Okay, trust me, this is a lot faster than trying to add up, like putting all 10 terms into your calculator and adding them together. Especially if I give you like, tell me the sum of the first 200 terms. Okay, that's just going to take you way too long. All right, over here, number 7, we want to find S sub 8. So the sum of the first 8 terms, so 8 divided by 2, the first term is negative 6, plus, we don't know what the 8th term is. We only have 1, 2, 3. We only have the first 4 terms. So we got to go find that 8th term. So again, we're going to use the arithmetic sequence formula. So a sub 8 is equal to the first term, negative 6, plus, let's see, how do I go from negative 19 to negative 6? Subtract 13. Negative 6 minus 19. Whoops, I'm sorry. Negative 6 minus 13 is negative 19. Negative 19 minus 13 is negative 32. Yep. Negative 32 minus 13 is 45. So we're subtracting by 13 each time. So this will be negative 13, and it was 8 minus 1. So a sub 8 equals negative 6 plus negative 13, 8 minus 1, negative 97. And that's the number I'm going to plug in there. So now I just type this into the calculator. 8 divided by 2 is 4. So we have 4 times negative 6 plus negative 97. Make sure you use the negative and not the minus sign there. Negative 412. So S sub 8 equals negative 412. Okay? All right, that's it for the notes.